Hello, my name is Ryan Webber, and I'm here to teach you a little bit about Isadora. Here we can take a look at a finished project. In this tutorial, we're going to build a tetrahedron with morphing corner points. There we go, full screen with that. So we're going to build something like this. This has got a few different video effects added to it, so we may or may not create something identical, but the idea will be the same. All right, so I've already done this once, and unfortunately I recorded the wrong screen. So we have take one. This is the last build that I did. You can see the effects are a little different, essentially the same project. So let's start fresh again. So building a morphing tetrahedron, we're going to build a value morphing user actor so that we can control the XY points. Then we are going to create a 3-line segment starburst as the starting point for our tetrahedron. Next, we will add the additional 3-line segments to finish the tetrahedron. And once that is drawing to our stage properly, we will add some video effects and package this up as a user actor so that you can add it to any project you like. All right, so that's the rundown on that. Okay, so line 1 here, let's create a value morphing user actor. Right, so a tetrahedron is made up of, what is that, 6 line segments, I believe. Each of these line segments has a start and end point. We are going to be using a 2D line actor, although there is a 3D line actor in Isadora as well. The 2D line actor is going to let us do this a little more quickly. So with a 2D line actor, we're really only looking at the XY coordinate. So we need to generate some points that are going to continually change so that we get that morphing effect. So to do that, and because we want them to be random and sort of self-controlled, we're going to use the random actor, random. There we go, right. So clicking on random, the input trigger on random gives us a random output from 0 to 100. And that's fantastic. We're going to want a random number for X, and we're going to want a random number for Y. We're going to want to generate 2 random numbers per point. We're going to want to generate those continually. So to do that, we're going to use a pulse generator. The pulse generator simply outputs a trigger at whatever frequency you have set. The default is 1 Hz, and we're going to use the default. It works perfectly for the case that we have here. So now you can see that we're outputting a different random number every second from a range of 0 to 100. Well, if we use that to animate our line would be shifting position instantaneously every time a new number is created, and that's not the effect that we're looking for. We're looking for a more animated, smooth effect. So to take these input values and smooth them out, we're going to use Isadora's fantastic smoother actor. One of my favorites, and a really nice way to create animation on almost any sort of value that is changing. We're going to need one of these for each of our throughputs. And with a smoothing factor of 0.2, the numbers change quite quickly. Now I'm going to do something here just to make it easier to view that. Stretch these out. If I click here, and I know that the values are going to be 0 through 100 because that's what we're inputting to it, that allows me to put the graphic view on for this element. And you can see that it just jumps pretty quickly with a tiny bit of transitional movement. I want much more transitional movement. So if I change that smoothing factor to 0.8, you can see I get a nice smooth movement from change to change. Right, so we'll do that for both. And I think I'll be happy with that. The next thing we need to know is that, well, let's look at it. The lines actor that we're using is a native lines actor in Isadora, has a start value and end value for both the horizontal and the vertical of the line. Each of these can take an input from negative 200 to 200. While in Isadora, our stage ranges from negative 50 to 50 and negative 50 to 50 again for the vertical. So the stage is measured essentially in percentage, where the center point of the stage is 0. Okay, so really we want our lines that we're going to be drawing for this tetrahedron to remain on the stage for the most part. So we really only want them to draw endpoints and start points within the range of negative 50 to 50, or whatever you define. We're going to give you some control over defining that, but for now that's going to be essentially the way we're going to think about it. So we're going to limit the range, and we're going to scale that range from 0 to 100 to negative 50 to 50. The actor that we use in Isadora to do this is the limit scale value actor. We're going to want one of these for both. And we're going to take the output of these smoothers and put it into there. Well, by default, it expects an input of 0 to 100, which is ideal for what we have, but it's still outputting 0 to 100. We're going to change that to the range that we're looking at, negative 50 to 50, and now we have a value generating component that is essentially, I think it's creating usable animated XY coordinates for us at this point. So what I'm going to do is I'm going to select everything in that value generator, cut it, create a user actor, paste the contents, add a user output, duplicate that with Control D, and set up my two outputs. And so that we have a little more control over the values, I'm going to go user input, and I'm going to make that the output minimum for both. I'm going to duplicate it. I'm going to make that the out max for both. And I'm able to connect the multiple inputs with this by holding down the shift while I do it, just in case you didn't know that. So shift key is fantastic for doing multiple inputs with a single line. Okay, so now we have user actor is changing. Oh, you know, why not? I didn't do this previously, but let's do it. User input. Let's just give ourselves the ability to control the frequency of these changes. Hey, that could be great. This might look really cool. Okay, we'll update all. And now we have a user actor, which we will rename it as point XY. And output minimum, we'll just go back to our full range as we were, and we'll change our frequency to 1 again as we had it. And you can see that we've got a nice morphing value. Perfect. This is what we want. So let's draw a line, just so that we can see how the line actor works. The lines actor works. Okay. I connect the output of the video out of the line actor into the projector, and I connect the start point and start horizontal and start vertical point to my point. But a line has 2 points, so we'll make a duplicate of that, which is going to generate different values because it has a random actor within it, or 2 random actors within it. So now we're generating random start and end points for this line, and we're not drawing anything. We don't see anything coming out. The line here is red. There's no video being produced. That's because the line actor only creates a line, and you can see drawing up here now, every time a trigger is input. So we have the ability here to set a draw frame rate. And we're going to use a pulse generator once again to allow this. And I'm just going to connect that up. And now you can see that we have a drawing frame rate of 1 frame per second. And it's not fantastic, but if I've dropped 6, now you can see we got kind of a choppy movement that's animated, and I don't hate it, but really we're looking at, we want 30 frames per second. I put in the wrong number there, but yeah, 30 frames is cool for what I'm doing here. All right, so fantastic, we have one line. Well, what we wanted to do, as we said here, is create a 3-line starburst now that we have our points generating. Well, a starburst is going to have one center point, and it's going to have 3 line segments, each with their own finish point. So what I'm going to do is I'm going to select the line segment and the end point and duplicate. And duplicate 3 times. So now we have potentially our 3 lines, all with a single endpoint, but they all need to have the same start point. So holding Shift, I will connect to Start and release Shift and click Start, so it ends that connection. Click, hold Shift, connect, release Shift, connect. All right, so that makes it pretty easy to connect this up, and you can see we're sharing that to all 3. If you don't want it, you want to get it out of the way, you can move it over to this side for now or whatever. I'm fine with it up here. Now we don't see our 3 lines yet because none of their outputs are being output to our projector. What we're going to do, and this is, we're going to daisy chain them because the lines actor has a video input. And this video in allows us to draw the line on top of the previous video. So we draw one line, and then we're going to draw another line on top of it. Now that isn't going to happen until this point is, well, let's just look at this. We have one line and we have another line drawing on top, but that one's not being drawn until this is clicked, right? And that needs to be done every single time an input is drawn. Well, because the way that this is working, there's a couple things we could do. We could connect this up to every trigger like this, and that will cause them to draw correctly. But you end up with this big line of things going across, and that's going to go to another 3 line segments in a little bit, and I just find this a little messy. Since we have an output coming that's only being drawn once with every trigger, we can actually daisy chain this as well. So by making the output of the video trigger the drawing of the next video, we got both of these drawing correctly. Now, if I take this output, and again, Shift Control to connect it to multiple things, just Shift, sorry, but yes. Now we have our starburst. Essentially, this is what we were looking for, and to make it look a little bit more like a starburst, I can make 1 point stick in the center, because that's our shared point between those 3 lines. We can force it to the center there, and that's pretty good. But I like to see it moving around a little bit. So using our point, now if we have it move 10% either way from the center point, we have kind of a morphing, I don't know, almost a octopusy looking starburst. I don't know what the word for this it really is, but you get the idea. Those are our primary lines. Now, we need, how to put this? These are all the points that we need. A tetrahedron only has 4 points, but it has 6 line segments. So we need to duplicate the line segments, bring them down here, maybe something like this. Grab these points so they're easier to work with. This point is center to these 3 and doesn't actually get used again. It's connected to all 3 components that it will ever connect to. So we're done with that point. Each of these is going to have to connect to 3 components as well, but you don't want them to connect to the same thing. So you're going to see we'll spread them out so that we get the right connection. In any case, we'll make this one the start point for this actor, or for this line, and we'll make it the end point for this line. That makes it have 3, so this one is now finished. This guy can be the end point to this actor, or to this line, but let's make it, instead of just putting it here, we need to spread these out. We'll make it another component for this one. Okay, he's done. Final point that needs to connect to things will become the start point for this one and the end point for this one. Okay, that's pretty fantastic. We might have our points connected correctly, and I think we do. We still have a little work to do, though, just to get things drawing an output. So let's daisy chain the rest of that. You can see everything lights up green, so it's outputting all the way along. I'm going to click and output, just I like my little square line. And you can see now we have essentially our tetrahedron. This is what we were looking to build. It's up here. If we want to make it smaller, well, we have these points. We can bring all the points together, make everything a little bit more cohesive, I guess. Those are our 4 points. These are all our lines, and this is our frame rate generator. Okay. Well, that's great. That's a tetrahedron, but right now it's kind of a messy little bit of a patch, and I could do better, but we don't really need to. I'm going to shrink the zoom a little so I can see the whole patch on the screen. I'm going to select everything except the projector because that's our output, and I'm not concerned about it right now. I'm going to cut this, and like we did earlier, create a user actor, open the user actor, and paste our internals to that. First thing we can do is just add a user output, and we should have our morphing triangle here. Notice that the triangle is morphing onto a checkerboard. We have a transparent background here, and that is happening because we have transparent in all of these components. Okay. Now, another thing worth noting is that this is being drawn at 640 by 360. That's pretty low resolution, and that's because in preferences, that's what I have Isadora set as a default for drawing, because it'll in some cases save you some resources. But I want to draw this at the full resolution of our output stage. So I can force that by setting the input of the first line actor to use a video that has that same resolution. A great way of doing that is to use the background color, which just creates a matte color, but as video format. And it's going to create a black frame. You can see here it creates black. And now if we look at any of our throughput, we no longer have a transparent video though, because we now have it on black. We also still have it at 640 by 360 because with 0 values set for its horizontal and vertical position, it's defaulting. Really what we want is 1920 by 1080. So now if we look at our output, we can see that we have a 1920 by 1080 output, and that's fantastic. It'll be the same all the way through, but we're not transparent anymore. So I'm going to change the color of that background simply to being fully transparent with an alpha of 0. Say OK. You see the checkerboard here, and again, our final output is now on transparent once more. That's fantastic. So we are creating an HD tetrahedron, which is not drawing to our stage yet because it's not connected to the projector, but we know we're doing that. But what if our output is going to change at some point? We're going to use different size projectors, and they're not always going to be 1920 by 1080. there's a little trick I like to use. I use the stage size actor, which the output of which I like to put into the inputs of the background color. Now you can see if I move ahead to a different stage that's not defined, then I get a 0 input, so it'll default to our default size of 640 by 360, and everything along the way will do that as well. But my stage 1 is defined as being a 1920 by 1080 stage. So by setting it to stage 1, and actually I can even set user input of this, it's going to be the stage that it's going to reference. I can generate these lines at the right resolution for my output by setting that in this manner. Great. Let's save and update all. I'm going to rescale to the default size and move things into view. We have this user actor that I'm going to rename to Tetra. If we connect this guy with a little zigzag there, I like to have those square, we can see that we are now drawing that same thing up here. It's drawing on stage 1, therefore we should have a 1920 by 1080, we do. So that all looks really good, but now we have no control over how it draws. And so what we're going to do is we're going to go into the Tetra actor, and we are going to give ourselves a few more controls. First one we're going to do, set a user input for the pulse rate. And like I mentioned earlier, we're going to rename this to frames per second, and we're going to set the input range of this actor to 1 to 30. And I'm only going to allow it to be 30 frames per second. And there you go. But frames per second don't usually come in point form. And, well, I guess they do, but I didn't want that. So what I'm going to do is I'm going to double click this, change it to an integer, and set the input range so that I can change it from 1 frame per second to 30 frames per second. And if you wanted to make it 60 frames per second, you could do that here too. So that's fine. Looks good, but really I would like a little more control over my points. I want to have, well, full control over all these point elements. So again, a user input, connect that, duplicate it, connect that, duplicate it, connect that. Great. There's our frequency of this, and just to be, I'm going to number all of these so that it's clear which point's which. Not that they really have a defined thing, but just to put them in the sets. Select all these, duplicate, oops, undo that, duplicate, grab it, move it down, connect, 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 grab all, keep grabbing the wrong thing, duplicate that, grab it, move it down. Obviously the numbering is not right here, so I'm going to have to go back and rename all of these in sequence. And then I will look just to make sure the sequence is correct, but 2, 2, 2, 3, 3, 3, and our final point is going to be 4, 4, 4. All right, so we have our points all set. We can individually set the frequency for how quickly those ones will be changing. There's a bunch of controls here we give ourselves. We have our output here. And what else are we looking at? Okay, well that looks good for now. Let's say save and update. Well, the default values just stopped our animation. So let's make the frames per second. That we know that this is our first one to make it minus 10, and that keeps it kind of in the center. Update rate of 1 frame per second. Let's make these minus 45 and 45, similar to before, 1 frame per second, minus 45 to 45, 1 frame per second, minus 45 and 45, and again 1 frame per second. Well, that's interesting, and I guess what we could do is now we could slow down or speed these up. Let me think here. How do we want to do that? Let's just put a different value in for each of these and see what happens. So now every point is changing at a different rate, which, I mean, sort of, maybe it's interesting. I don't know. There's maybe some ways that we could make that look really cool. I'm not entirely sure, but we can slow down some. So now the center point is changing. Well, let's make the center point move around a lot, but it doesn't move very far. So now it's just jiggling there. And, you know, I don't like it, but it's something. We have control over it. So if we change them all back to what I was originally playing with, 1 frame or 1 sort of value per second being smoothed out, we're back to where we were. And that's pretty cool. I like it. Works for me. But I kind of wish it had some color. It's sort of boring. We have all of our lines drawing as white, and we could start changing this, and each line could be modified individually. You know, that's cool. But I'd rather have the whole thing morphing itself along this time around. So yeah, to color the entire tetrahedron that we've drawn as a single video component at this point, because at this point in the user actor, all 6 of the line segments are drawn together into a single flattened layer that has a transparent background. We can color that video layer very easily using the colorizer. Imagine that. Colorizer to get some color. Right, so a colorizer uses RGB, and each one of the RGB inputs ranges from -100 to 100. And yeah, it has that range, -100 to 100. And there's 3 of them. So 3 values that we would like to have changing at some sort of rate. Right, well, our points are kind of like that. They allow us to set a range of the output to change, and they set a rate for them to change. So I'm going to copy 2 of those. Gives us 2 values more than we need, but for right now, this is a real quick fix. You could create a new version of the user actor or whatever, but right now this will do the trick in a pinch. And you can just link up these values now that I've set the range, the entire range. And you can see that we have a pretty dramatic morphing color now, which I'm pretty good with. It's fine with me, right? What we could do is we could make 0.1's speed, have control of the color morphing speed. So now the center jiggle speed is going to actually be the one that controls how quickly the colors change. Or we could just not include that value or these inputs at all and leave them alone. I'm just going to leave them at 1 second because I want to move along from here. Cool. Okay, so there's our basic tetrahedron. And at this point, it's color morphing. Could have separated that, could have left it in, whatever. We got a tetrahedron, and I'm happy with it, and it works. If you wanted to, oh, well, you could easily do this, duplicate, and horizontally offset this 25 and set that 25. And now you've got two of them kind of push the different edges of the screen and they're running together. You could confine their sizes via the XY spreads so that they're smaller and then position them, right? Bunch of things you could do here. And yeah, it's cool to be able to do that. Fine. So that's one thing. What I wanted to do next is show you how to add some fun video effects to this. And we're going to look at the video delay, the motion blur quickly, and multi-mix to bring them all together. Also, I'm going to add a Gaussian blur twice. I'm going to do that. Okay. So that's our clean input, right? From there, what I'm doing, a Gaussian blur of 2 is the lowest value that actually has an output on this Gaussian blur. And essentially what it does is it gives it a really light blur, but what I find it does is cleans up the any anti-aliasing there is. So I'm going to stick that on the top of the stack. That's going to be our final drawing. I'm going to take the input there so that we can see what we're doing. So all we've done at this point is cleaned up a little anti-aliasing. Below that, I'm going to stack a bit of a blur. It's a little hard to see, so I'm going to duplicate it. But maybe I'm going to make that 32, just bigger, a little more neon-like. Yeah, the neon's fun. Okay. Right, okay, so the neon is cool. What do I want to do next? Because every time I've done this, I've done a little bit differently. I'm just kind of designing as we go. Let's do let's do a video delay. I'll keep it a full second behind at 30 frames per second. We got 30 frames is a second. And I could add that to the mix right now. You can see it's drawing there. So there is that. One way to get a bit of a delay, right? And I want to get this motion blur into the mix too. So I'm going to duplicate this delay one more time because I want my motion blur to be running a little bit behind the mix again, but this time only 10 frames. I'm going to bring that into there. I want a little less than this. I happen to know that. And I can bring that up to 8. The default would give you an interesting effect though as well. And again, I'm going to stack that in the motion mix like this. So now we got all these morphing sort of bits of this thing together. And I don't absolutely love it. I think we need a little bit more, not delay, but I think we need a little more of that, yeah. Maybe we just don't need that extra delay there. We want to simplify this a touch because it was getting a little too busy for my liking. And using the blurred effect, what if I brought in the straight effect into the delay and ran that into the motion blur? It's a little harder, but it's not terrible. And I wouldn't mind seeing a little more center punch to the neon that we have there. All right, yeah. So this is really all I wanted to do. I wanted to show that you could take something and encapsulate the functionality of it into a unit like this and make it kind of interesting. So I now want to make 4 copies of this and run them into quadrants of the stage's output. There's a lot of different ways I could do this, but one of them is I'm going to minimize the movement on almost everything here to keep it within a 25% or 25% range. Yes. So minus 12, plus 12, minus 12, 12. So yeah, that'll keep it within that zone. Minus 12 and 12. I'm not really thinking very clearly here, but I think we got something small enough now. Not that I know what I'm aiming for right now. I'm just going to play it around, but whatever. And bring all that back to the center because I want to see something that looks nice. And that should be rendering at full HD, right? And bring that full screen. And there we go. This is something that looks a little more pleasant. And I noticed something there. I think our end caps aren't as nice as they could be on those lines, and maybe that's something I missed earlier. Yeah, they all have a square end cap, and I'm seeing that in there. So if I change these all around, where they meet and have that point, won't have little tusks sticking out of it. It'll make a much nicer component. Yeah, so save and update that. Let's see now. Oh yeah, so where now the junction points where the lines meet are much smoother and prettier. And we have sort of a neon looking tetrahedron floating around with some different effects. It's cool. Okay. Thank you for joining me. I hope you were able to stick with me as I jammed my way through that little build. And I hope you were able to learn something. We covered a number of different topics. All right, thanks again. Bye.